So what happens when you do not have a right triangle? In that case, you need to use either the law of sines or the law of cosines. With the law of sines, let's say that you're looking for a side like B. That means you need to know two angles. If you only know one angle, then you're probably going to be using the law of cosines. If you know two angles, probably the law of sines. So on page 1, there's just pictures that are already given to you, and then I'm going to do an example like that. So what if this is the triangle, and we're going to be looking for theta right here. So this is actually very similar to number 2. And let's say that this side is 12 and this side is 14 and this side is 8. Now I just randomly made up those numbers, 12, 14, and 8. So it could be possible that there is no triangle with those sides. But that's okay. The math is going to tell me the truth no matter what. So in here, I do not have two angles, so I'm not going to be using law of sines. I'm going to be using law of cosines. And the law of cosines says if you're going to be using angle A, then the whole formula needs to start with the side that's across from it. So in this case, across from the theta is 14. So the whole formula starts with a 14 squared. And then that equals, you square each of the other two sides, and then minus 2 times the 8 times the 12 and cosine of theta. So now I need to isolate this cosine of theta. So subtract 8 squared and subtract 12 squared from both sides. And I don't actually need to put like 64 right there because I'm going to put this in a calculator in just a moment. Okay, next, to isolate this cosine, divide both sides by these numbers. So we've got, you know what, I might as well just start using the calculator right now. We've got 14 squared minus 8 squared minus 12 squared. That equals a negative 12. So negative 12 is going to get divided by negative 2, an 8, and a 12, and now that equals just cosine of theta. And then take cosine inverse. So what is cosine inverse? And I could just, I could have the 12s cancel and I could have the negatives cancel. So that would just leave a positive 1 on top. And then after that, all that's left is a 16. So what's cosine inverse of 1/16? So in here, I want the angle to be in degrees, so the calculator is in degrees, and find cosine inverse of 1/16. And yes, that is possible, that it's 86.417 degrees. Okay, when you get to page 2, there's word problems. So this is similar to number 4. A person runs 8 miles bearing. So when it's got bearing, first of all, draw the north line. And then she's going to the east by 15 degrees. And she ran 8 miles. I think I'll put that in red. 8 miles. Then she runs 15 miles and the bearing is from the south. So from that point, draw the south line. And then towards the east would still be going this way by 20 degrees. And this time she ran a little bit farther, so I'll make this one a little bit longer. So this is 20 degrees and this is 15 miles. So then how far is she from the start? So she's right here and the start is over here. So then I could use my little straight edge to draw a nice straight line. And then we need to solve for this side, which I'll call x. This angle right here is missing, but I know that this is actually 15 degrees, because if you have two parallel lines and then there's a line that goes across it called a transversal, then this angle and this angle have to be the same. So if this one is 15 degrees, this one has to be 15 degrees. And since the north and the south line are parallel to each other, this is the transversal. So if this is 15 degrees, then this is 15 degrees. So if I take that picture and just draw the triangle, maybe I should have used my straight edge. That's okay. Then we're looking for this side x. This is 15. This is 8 miles. And then add these two together. So this angle is 35 degrees. And then use the law of cosines. So with law of cosines, you go across from the angle that you're going to be using, 35 degrees. And that is where the formula starts. X squared equals 8 squared plus 15 squared minus 2 times 8 times 15, and then cosine of 35 degrees. Now, since all of these are numbers, I can just type that into the calculator. No other algebra required at this point. So you've got an 8 squared plus 15 squared minus 2 times 8 times 15 and cosine of 35 degrees. So all of that equals 92. That means that x squared equals 92.404. And then take the square root. Second square root 92.404. So she's about 9.6 miles from the start. Okay, one more, and this next one is like number 6 on the second page of the problem set. So on the actual problem set, I said, like, this was a tugboat and this is a ship. This is going to be city A and city B. So this is going to be the ground. The plane is up here flying along at a constant altitude. And then the angle of depression. So that means if you look at a line parallel to the ground and then you look down, that's the angle of depression. So the angle of depression the first time is 25 degrees, and that's going to be city A. So that means from the top down, that's 25 degrees. Next, the angle of depression to city B is 45 degrees. So that means that it's actually going to be below this because 45 is bigger, so it's going to have to go farther down. So it's going to be like this. And right here is city B. So going from here all the way down to right there, that's 45 degrees. Since this already takes up 25 degrees, that means this extra part right here is 20 degrees. So that way the two of them add up to that 45. All right. Then the plane is 70,000 feet. So I'm just going to put 70K for 70,000. So the plane is right here. The distance between the plane and city B is 70,000 feet. Find the distance between the two cities, x. Now, On the other ones, I just automatically went to the law of cosines. But with this one, I'm not going to be able to use law of cosines because this side is missing. And this side is missing. So with law of cosines, you have to have 2 out of the 3 sides. And we only have 1 out of the 3 sides. So I'm thinking it's law of sines. But then again, with law of sines, you need 2 angles. And right now, I only have the 20 degrees. But we can use that idea that we used on the last one because this top line and the ground are parallel. That's because of this. So that means that if this is 45 degrees down to this line to B, then this is also 45 degrees. And because this is a straight angle, that means that this one equals 180 minus 45. So to simplify the picture, I'm just going to redraw it real quick with just the important information. Here's x between A and B, and then here's the rest of the triangle. And I've got that this is 20 degrees, this is 70,000 feet, and 180 minus 45. No, I need 180 minus 45 is a 135. And now what I need is to find this last angle because I need the angle that's across from 70. So of course with the triangle, all of the angles add up to 180. So if you take 180 minus the 135 minus the 20, it equals 25. So this angle is 25 degrees. Okay, now I'm ready to do the law of sines. Just move over to this side where I've got some space. So since I'm looking for x, I'm actually going to start with that. So it's going to be x divided by sine, and you need to go across from the x. That's 20 degrees. And then this side is 70,000, and across from the 70,000 is 25 degrees. All right, we're almost done. Now to solve for x, multiply both sides. So now I'm going to go ahead and write out the 70,000. Multiply both sides by the sine of 20. And that will be it. So how much is 70,000 and then sine of 20 divided by sine of 25? And then before I hit enter, I just double check it's in degrees. Yes, okay. So it's 56,650.202. And this is in feet. And then I'm just curious, how many miles is that? About 10.7 miles apart.